Today we're going to look at the idea of polygons and what makes up a polygon, how do we name a polygon, that sort of thing. So polygons are our topic du jour. Now, when we name polygons, generally we look at one of two things, either the Greek or the Latin prefix to the name of the polygon. And Greek and Latin prefix are things we use all the time, things that you've seen before, nothing new here. You might want to copy this into your notes. So you may want to pause the podcast for a second and copy this little table into your notes. We name a polygon based on the number of sides or the number of angles, because the number of sides equals the number of angles. In fact, the word polygon itself means poly, many, gon, refers to angles, not sides. So let's talk about the number of angles. If it has 3, we use a Greek prefix tri, and we call it a triangle. Notice less than 3 sides doesn't get a name, because less than 3 sides doesn't give us a polygon. 4 sides, if we use the Greek, we'd use tetra. We call it a tetrahedron. Where have you seen that prefix tetra for 4 before? Maybe if you've ever played the game Tetris. There's always 4 blocks in Tetris. So tetra is a prefix meaning 4. It's a tetrahedron, or in Latin we call it quadrilateral. Quad is the prefix in Latin for 4. So tetrahedron or quadrilateral. 5, we generally only use the Greek prefix pentagon, the big building in Washington. 6 is a hexagon, and again that's the Greek prefix for hex, for 6. 7 is one that has both, the Greek and the Latin. Could be considered a heptagon or a septagon. If you ever watch the Olympics, there's kind of an obscure event in the Olympics for women called the heptathlon. It's 7 events. So that's another place you see that prefix for 7. 8 sides, now we go strictly with the Latin, is an octagon. 9 sides is nonagon. No is the prefix for 9. 10 sides, decagon. 12 sides is a dodecagon. Do is the prefix for 2, so 2 and 10 agon essentially. So all these different names. Your daily check, by the way, right away here, I want you to go online, look up this name for a 20-sided polygon. Should be a pretty quick little Google thing. But that's my check for today to see if you're actually watching the podcast. Now, just interestingly enough, if I just look at these here, sept, oct, no, dec, I think you see the months of the year, September, October, November, December. But you're saying, wait a minute, September isn't the 7th month, it's the 9th. October isn't the 8th, it's the 10th. We're off by 2. Why are we off by 2? And it's kind of an interesting little trivia fact that I'll just share with you real quick. There were originally only 10 months to the year in the calendar, but the Romans, a couple of their Caesars decided they were so important, they were so wonderful, they were going to name some months after themselves. So Julius Caesar decided the middle of summer would be a great time to name a month after himself. He called it July, which pushed everything back a month, pushed all their other month names back one. And then Augustus Caesar decided, well, he was at least as good as Julius, so he got to name a month after himself too. And we get the month of August. So that's why our prefixes, our Latin prefixes, no longer match with the numbering of the month. However, the prefixes are still valid. Sept is for 7, oct for 8, no for 9, dec for 10. And if you remember your months of the year, it can help you remember those names as well. Some things not allowed in a polygon. A polygon is a closed figure that has no curves and the sides never cross over themselves. So all 3 of the drawings we see here are not polygons. This one is not a polygon because this is not a straight line side or a segment side. It is a curve. We do not use curves in polygons. This is not a polygon. It might be considered 2 polygons, 2 triangles touching each other, but as by itself, it's not a polygon because the lines cross over each other. Not allowed. This third one here is not a polygon because it's not closed. We've got an open space here. We're not allowed to have an open space. So that makes it not a polygon. So those would be 3 examples of things that are not polygons. These both are polygons. In fact, I'm going to take this out of here for the moment, if I can grab it. I'm having difficulty grabbing lines right now. Hold on, let me use the mouse for a second. Aha. Let's see if the mouse will want to grab it. Oh, that's how to give me difficulty too. So, there we go. There's my mouse. Come here. There we go. Okay. These are both polygons. They're closed figures. They do not cross over each other. We have convex and concave. Convex simply means it's convex. None of the sides are interior to the other. Concave looks like it's caved in. It's a pretty easy way to tell the difference between convex and concave. One way we can look at this more specifically is say, okay, a convex polygon, all the diagonals are strictly inside. So if I were to draw all the diagonals of this polygon, all of them, to start with, you'll notice we get a star form shape. It's kind of cool. But they're all completely inside the polygon. If I start drawing the diagonals of this polygon, well, yeah, okay? Notice some of the diagonals are on the outside of the polygon itself. That's a sign that that polygon is concave. But most of us can tell just by looking. We don't have to draw diagonals to see if the polygon is convex or concave. We can tell this one looks caved in. That makes it a concave. The technical definition says if non-consecutive vertices are connected outside the polygon, it is concave. That's the technical definition. You can look that up more if you like. So let's practice, classify. Is it a polygon? Is it concave or convex? And then give it a name. Look at this first one. Is it a polygon? Yes. All 4 sides. No curves, no crossing over, no open spaces. How many sides? There are 4. It is convex because it is not caved in. And with 4 sides, we'd call that a quadrilateral. And convex. Is this arrow a polygon? Sure is. Nothing crossing over, no curves. It's a closed figure. It is concave because some diagonals are on the outside. So it is concave. And it has 1, 2, 3, 4, 5, 6, 7 sides. So it'd be a septagon. We could also call it a heptagon, if you prefer. Either answer would be acceptable. Here I have a convex. How many sides? 6, so hexagon. Here, again, a little interpretation. Do I have 2 triangles or is it not a polygon? Well, again, we want to analyze it as one shape, so this would not be a polygon. Very important vocabulary right here. Stuff you probably, again, want to copy down into your notes. Equilateral. Pretty easy to understand why. Equal meaning equal, lateral. Lateral means sides. So all sides are congruent. Equiangular, even easier. Angular, all angles congruent. And finally, regular means it is both equilateral and equiangular. If it has both properties, equilateral and equiangular, that's what we call a regular polygon. So make sure you know those 3 words. Again, more practice of the same idea. Is it a polygon? Name it if it is. This first one, yes, this is a polygon. It has 1, 2, 3, 4, 5 sides. It is a concave pentagon. This is not a polygon. Curves, not allowed. This is a polygon. No curves. Closed figure, 1, 2, 3, 4, 5, 6 sides. A convex hexagon. This is a concave quadrilateral. So again, concave because that one, the two consecutive vertices there, or non-consecutive vertices, are connected outside of the polygon. It's a diagonal outside. That's it for today. Identifying polygons. That's the kind of thing we're going to be working on. Know those names. You may need to rewind, recheck your notes, make sure you've got some of those definitions in your notes.